Transport and infrastructure are the backbone of modern society, facilitating trade, connecting communities, and driving economic growth. Globally interconnected economies, urbanization, rising populations, technological advances, and climate change are reshaping transportation and infrastructure, pushing us to rethink how they are managed. Low- and middle-income countries are facing a dual challenge: ensuring equitable access to efficient, safe, sustainable, and affordable transport, and reducing the impact this has on the climate. International financial institutions such as the World Bank, Asian Development Bank, and Inter-American Development Bank are committed to supporting these countries in overcoming these challenges. They provide financing, such as grants and loans, and technical assistance to help governments with their infrastructure development programs. For these institutions and their partner countries, access to high-quality data is essential. They need comprehensive and accurate information to plan transport networks, build infrastructure, and monitor economic, environmental, and social impacts. The European Space Agency, ESA, collaborates with various organizations to integrate Earth observation into development operations. It has launched the Global Development Assistance Program with a dedicated activity on transport and infrastructure. Traditional methods to obtain information in this domain, such as national statistics, ground observations, and remote sensing from planes or drones, are often incomplete, expensive, and quickly outdated. In contrast, satellite data is global, objective, comprehensive, repeatable, and timely. Shaping the future of mobility, the Global Development Assistance Transport and Infrastructure activity focuses on 4 key areas where Earth observation has the potential to transform transport and infrastructure. Earth observation provides critical insights into monitoring and characterizing infrastructure construction. Monitoring infrastructure often means frequent site visits by project managers and inspectors, which is not only time-consuming but also costly. For remote or unsafe locations, access can be problematic, resulting in delayed issue detection. Satellites provide a powerful solution here. By helping detect changes in infrastructure such as roads and buildings, they offer valuable insights into construction progress and development over time. Earth observation also supports the characterization of transport infrastructure demand, which is particularly important given the growing need for transport infrastructure in low- and middle-income countries. It is used to generate high-resolution maps related to key spatial drivers of transport infrastructure demand, including building height, volume and density, surface imperviousness, the growth pattern of human settlements, and the spatial distribution of a population. This allows planners to identify congestion points, forecast infrastructure demands, and strategically prioritize investments. Earth observation helps assess the condition and inventory of transportation infrastructure. In low- and middle-income countries, one of the main obstacles to economic growth is the weakness of transport infrastructure. Combined with the escalating effects of climate change, poor or deteriorating infrastructure poses significant challenges. Satellite data provides an efficient solution for assessing the condition of roads. InSAR technology offers millimetric precision in detecting ground motion and potential structural degradation, which in turn can be used to identify unstable areas around railroads, roads, and bridges. This provides users with essential information to mitigate ground movement risks, enhancing early warning systems and carry out cost-effective road maintenance. Earth observation is particularly useful in countries that lack up-to-date infrastructure inventories. Through satellites, it offers a scalable, non-invasive solution to identify and map existing roads and predict how these might change over time. Information on how road networks change over time in turn supports infrastructure development in the future. Finally, satellite imagery helps track urban growth over time and monitors unplanned urban expansion. It is also used to estimate travel times to key services, identifying underserved areas. Earth observation helps assess mobility patterns and map road safety hazards. This is particularly true in regions where traditional mobility data, such as data from mobile operators, may be unavailable or unreliable. Satellite-enabled data is used to pinpoint congestion points in cities and track cargo activity at ports, providing insights into trade flows. It can also be used to detect boats and ascertain the peak activity period. Earth observation can also help improve the safety of transport infrastructure by detecting areas prone to road safety hazards. For instance, land subsidence can cause the road surface to crack, deform, or develop uneven surfaces. Earth observation in turn can be used to detect ground deformation, enabling planners to close off roads that are considered unsafe. Similarly, by detecting changes in vegetation, it enhances road safety as vegetation growth near roads can result in visibility issues for drivers and cause accidents. Earth observation provides critical insights into assessing climate-related vulnerabilities to infrastructure and, in turn, determining the impact of infrastructure on the environment. By combining satellite data with weather information and climate models, planners can better anticipate climate-related risks. For example, extreme weather events like floods can be a detrimental risk to infrastructure. By monitoring the impact of a flood over time, it is possible to map flood risks and identify high-risk areas. Flood risk maps generated using satellite imagery reveal how low-lying areas are exposed under different scenarios. Satellite imagery can also track how waterways evolve over time, capturing seasonal or long-term changes that affect access and connectivity. Such information in turn helps inform infrastructure adaptation efforts. Flash floods are particularly dangerous due to their sudden onset, high intensity, and the challenges they pose for preparedness and response. Earth observation also facilitates the assessment of environmental impact of planned infrastructure, such as the impact on air quality and assessing environmental factors like soil degradation, water resources, and biodiversity. Such information allows planners to balance infrastructure development with environmental conservation, ensuring sustainable practices are implemented. The initiative is funded by the European Space Agency and managed by a consortium of European space sector organizations.